Let's take a look at what happens when a quadratic function has no roots or zeros. Or in other words, that quadratic function will never touch the x-axis. Let's see how that affects the quadratic formula with this problem. The function 3x squared plus 4x plus k equals 0 has no zeros. What is the value of k? So fear not, there is a simple way to solve this, and it involves the quadratic formula. So let's go ahead and review that formula quickly. It's x equals negative b plus or minus the square root of b squared minus 4ac, and the whole thing is divided by 2a. And the part we need to focus on in this formula is called the determinant. And the determinant is everything under that square root symbol. So b squared minus 4 times a times c is called the determinant. And the determinant has a variable for a, b, and c, so we need to fill those values in, and let's list those in step 1. A is going to be the first number in the quadratic equation, which is a positive 3. B will be the second number, which is a positive 4. And then we come to C. C is an unknown. It's positive k. And that will be what we're solving for in this problem. In this step, we'll set the determinant to be less than 0, and then we'll solve for k. So the really important point here is that if you're trying to solve for a quadratic that has no roots, anything under the square root symbol has to become a negative number. The determinant must be a negative number. And that's because we can't have a negative number under a square root symbol. It's not allowed, which makes 0 roots. It never touches the x-axis. So since we're solving for a quadratic that has no roots, let's go ahead and set the determinant to be less than 0. Just like that. And now we'll fill in our variables. So in step 1 we found b was 4, and a is 3, and c was the unknown. It's k. And the whole thing, the determinant, is still less than 0. And now it's a matter of isolating for k. Let's start to put some stuff together. So 4 squared is 16, minus 4 times 3 is 12, k, less than 0. Now I'll move the positive 16 to the other side, leaving negative 12k less than negative 16. So far I've treated this less than symbol just like an equal sign, but now it's going to be different. I'm dividing both sides by a negative number. I'm going to divide by negative 12 to isolate for k. And the rule is, if I'm dividing what's called an inequality by a negative number, I have to reverse the sign. So pay attention to that if you ever come to that situation in these type of problems. So I just changed it from less than to greater than because I divided by a negative number. And finally, I can reduce that fraction to 4 over 3. 4 will divide nicely into both of those numbers. So I'll end up with a final answer of k is greater than 4 over 3. So what we've just said is that for this quadratic equation, k can be any number bigger than 4 over 3, and it would have 0 roots, or no zeros. In other words, it would never touch the x-axis. So remember, for no roots or no zeros, the determinant must be set less than 0, and then you solve for the missing variable. So are you ready to give it a try on your own? Grab your paper and pencil and try to solve this problem. The function negative 2x squared plus 6x plus k equals 0 has no zeros. What is the value of k? So try that using the same steps I showed you on the left, and I'll post the solution when you're ready. Turns out k can be less than negative 9 over 2, another fraction. And we got that by listing our a, b, and c in step 1, making sure that a was negative 2. Then we fill those values into the determinant, which is set to be less than 0. And finally, we have to isolate for k. And then we reduce this fraction to get negative 9 over 2.